Okay, so now we've had a little look at, just some basic. Let's go and actually follow our theory of this. So we've got theoretical probability. So let's just write the rule above it, because this is what we wrote. It's the theory of the event. So if we looked before, remember it was the number 4. So here we go, number of favorable outcomes. So we were looking before, we were saying how many 4s did we get when we spun it so many times. So this was like the total outcomes was how many times we spun it. So this is the rule we're going to find. So here we have a little examples. It said, with the word television, find the probability that the letter is V. So if you were taking a letter out of that word, television, what's the probability that you would pick out a letter V? So if we did this, so the probability V is the outcome we want. How many V's are there in television? There's 1, so that's the number of favorable outcomes I can get. Now, how many letters are in the word television? 10. So that's the probability of a V. If I looked at here and I did the probability of an E, now how many times could I get an E? How many E's are there? There's 2, isn't there? And there's still 10 letters that I could pick from. Now, we like to probably simplify that, so I'm going to make that 1/5, okay? Now, also, if they talk about in decimal, let's just put down under here, if you had 1/10, that's the same as 0.1, you can say 10 if you like, okay? And if we have 1/5, or you can always just look at the tenths. If we were doing a decimal, it would be 2.20. So let's just have that underneath. If you leave it in fractions, you're fine. I'm going to mark it right. Okay, the probability that it's not an E. So what are all the letters that aren't an E? That's T, L, V, I, S, I, O, N. So how many is there? There's 8 out of 10. We can simplify that. So we could write it like that. Obviously, a decimal is 0.8 because 8 out of 10 is 8.8. Okay, and then we could do the probability of an E or a V. So that means it could be E or V. So how many options is there if it's an E or a V? 3, good, out of 10, which we could say is 0.3. Okay, so that's pretty easy. That's what you're going to get asked to do questions like that. Now, I'm going to pause it and you guys give this a go. Okay, so the probability of a T, there's only 1 T out of 11 letters, so that's 1 out of 11. Probability of an A, there's 2, so 2 out of 11. Not an A, there's 9 other letters that aren't A. And the probability A or T, so there's 2 A's and a T, so there's 3 options out of 11. All right, so that's that one. Let's keep going on. So now we're going to do experimental probabilities. So this is observed probability. So it means when we look at the results. Okay, so let's write that down in case we're looking up this and we see this. So uses results as favorable outcomes. So we're going to, even though we think it should happen, we know in real life it doesn't happen. So let's have a look at experimental. So it said an experiment involves tossing 3 coins and counting the number of heads. Here are the results after running the experiment 100 times. So they throw 3 coins at the same time. So there could be, and it's just what happens in that outcome. So you could get 0 of those 3 coins showing a head. You could get 1 of them showing 2 or 3, all 3 could be a head. So and there's the results there. So when it says down, we're going to do the probability. So if we look at A, the probability of obtaining 0 of those 3 coins showing a head we would say, we can see here, there's the outcome. So we've got 11 and there's 100 times they did it. If you add these numbers up, they equal 100. So there's the 100 outcomes. Okay, so the probability would be 11 over 100, or we could say 0.11 as a decimal. Okay. If we do the probability of, so B, of getting 2 heads, like there. So here, if we look at 2, we've got 36 out of 100. We can simplify that. What did I say? I think 6 goes, no, what did I say? 3 goes into that 9 times and whatever, 25. What is it? 2 actually. 4 goes into that. 4 goes into that 9 times and 4 goes into that. So we could say, or decimal. So use this 1 out of 100 to create the decimal. It's just 0.36. You just go to the 100th decimal place, and that makes it easier if you want to just do a decimal. I'm not sure what the back of the book is doing, whether they're doing fractions or decimal. Okay, so the probability of getting fewer than 2 heads. So fewer than 2 heads. So what would the actual outcomes be if it was that? So if it was, it wouldn't be 2, fewer than 2. Would it be these 2? 0 and 1. Would you agree? Yeah. So we're going to say, if I add those 2 together, that would be 51. Would you agree? I'll just that's how I did that, out of 100. So we end up with, or we could do that as a decimal. Either answer is fine. Okay, and then the last one, sorry, I'm running out of little room. Probability of at least 1 head. So that would be this 1, 2, or 3. So if you, let's put that in there. So if you add all those up, it's actually 89 out of 100, which is 0.89. All right, so let's just write a little note. If you leave your answers in fraction form, you must simplify it. So put it as your simple. Don't say 5 out of 10. It's 1 out of 2. Yeah. So you must be in simplest form. Try to do it as much as possible. Otherwise, you can just put it in decimal. Just read what they answer. So I'm going to pause it, and you guys are going to give this a go, and then I'll redo it and see how our answers go. All right, so if we have a look, the probability of a 0 is 10 out of 100. We can see that was the outcome. The probability of a 3 was 9 out of 100. So I'm changing, the fraction is the exact answer, and then you can also have a decimal. This one didn't say either way, so whatever you left it as, that's fine. The reason I'm saying that is when you move into methods, you do need exact answers. It's assumed to put an exact answer. So that's why I'm trying to teach you now. The probability of fewer than 3 faults. So if you're fewer than 3, it's either 0, 1, or 2. So they added up to be 87 out of 100. And then the probability of at least 1 fault. So actually, did I do that one wrong? At least 1 fault. So what would that be? Yeah, because it would be at least 1 fault would be a probability of 1, 2, 3, or 4. So if you add all these numbers up, yeah, it was 90 out of 100, or 9 out of 10, or 0.9. Very good. All right, so I'll just quickly write this and go through this on the video. Oh no, I won't.